Okay guys, here's our introduction video on the periodic table. In this unit we're going to talk about the periodic table, how we use it as a tool, some trends that we can see on the table, and we are going to kind of dig deeper into how it's organized. So we're going to take a few notes, so please watch the video and come to class tomorrow able to discuss it and do some demonstrations. So first thing we want to talk about is Dmitry Mendeleev. Dmitry Mendeleev was a Russian physicist, and his contribution to our scientific community was basically developing the first periodic table. He was working in the 1870s, so kind of about the same time as the early stuff about what the electron is, the proton, in terms of that stuff. What he did is he took the 65 known elements and he arranged them according to their atomic mass. One of the key things that he did, which made it a very powerful table, is he put them into groups and into periods, so that he organized them by their properties and not only just by their numbers. In addition, he left some space for future elements, so he actually predicted that there are elements out there that we had not yet discovered, and he actually predicted those elements with pretty high accuracy. If we take a look at his table, here's just kind of a picture of it, obviously written in Russian. If you look, we have your lithium, beryllium, and then you have boron, carbon, nitrogen, oxygen, fluorine. Very much the same as if we jump over to our modern periodic table, where we see lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, all sequenced in that same kind of group. So if we go back to his table, we see, in the second group, he has exact same elements that we had now in our second group. So he actually did a really good job of organizing that first table. In addition, you'll see that here's calcium, and then there's a question mark at 45. So he's like, well, here's 40, here's 50, here's titanium. There must be something else here. Same deal down here. Here's zinc, 68 and 70. He predicted their mass numbers, but he did not know exactly what that element was yet. And again, if we jump back to our modern periodic table, we see that we had calcium. When they knew about titanium, and his question that was 45 was scandium. And if you look at scandium, its mass is 44.9. So he predicted the mass without even knowing what that element was. Same thing between zinc and arsenic. We did not know about gallium or germanium, and he predicted these elements would be discovered. So not only being able to organize the table, but also being able to predict future elements was pretty cool accomplishment for the late 1800s for Mendeleev. The next time the table was modified any significant amount was in 1914 by Henry Moseley. What Henry Moseley did is he took the table, added in some new elements that had been discovered, and he rearranged it slightly to now match the atomic number of the elements versus the atomic mass. So he flipped a couple elements around, gave a better organization to the table, and now if you look at our table, we now have a table that starts with 1, goes to 2, 3, 4, 5, 6. So it's now sequencing by the atomic number and not necessarily the mass. Okay, so just basically a rearrangement of the elements that made it better. There are other people who've done changes throughout the time. For example, a guy by the name of Seaborg, he was a person who actually pulled the group F, the F group, out of the periodic table and slid them down and kind of did that. So again, he added some parts to it too, but the only two people that we really need to talk about are Mendeleev and Moseley in terms of the periodic table. Here's our modern periodic table. We've already talked about this in our previous unit. There's 18 groups across the top. We call them groups. That's the proper terminology. They are the columns in there. And then we have our 7 periods. So we numbered off in our last unit 1, 2, 3, 4, 5, 6, 7 down that. So when you look at the table, we talk about 18 different groups of elements within 7 different periods. Recall those 7 periods also match up to the 7 different energy levels, which the electron configurations match. We do have some key places on the periodic table. So if you have your periodic table out, I should say if you don't have your periodic table out, you might want to get it out at this point. And we want to identify and label some of these different parts of the periodic table. So as we start to talk about them, you know where to go to look at them. The first is the group here in yellow, okay, it does not include hydrogen. Hydrogen is more of a green color, so this matches more with these green ones over here. But this block of lithium down to francium, they are called alkali metals. They have very similar properties because they have very similar electron configurations. So all of them end in S1. So lithium ends with an S1, sodium is an S1, potassium is an S1 in terms of their electron configuration. So their properties will be very similar. So these are all grouped into one group, and we call that the alkali metals. Right next to that, in the light blue, we call these the alkaline earth metals. Um, they have some properties that are similar to the alkali metals, but they are also very similar to each other in terms of their properties. So our second group across, we call them the alkaline earth metals. All the way across to the other side of the table, we get the halogens. They're in group 17, include fluorine, chlorine, bromine, iodine, astatine. So this group is one of our more reactive groups, so they kind of get their own name for those. And then finally, over here, we have our noble gases in group 18. We've already talked about the noble gases, how they're special because they don't react with anything. They're the most stable elements. So we call this group over here, group 18, the noble gases. In the middle block, which we called this the D block in our last unit, the D block, the whole thing, groups 3 through 12, ignore the fact that this says B and 4B and 5B. This was an older naming convention that we don't use anymore. You might still see these on some different periodic tables, but now we just number 1, 2, 3, 4 across. So everything in this whole block, okay, everything in the dark blue here, we call transition metals, okay? So when we talk about in our notes, the transition metals do this, we're talking about anything inside of here is considered a transition metal. Down here, the F block, we give it the term inner transition metals. Okay, so we have transition metals, alkali metals are this group, alkaline earth metals are this group, your inner transition metals are down here, your halogens are right here, and your noble gases are right here. Two other groups on the periodic table that we can see is this pink area here and this green area here. While these regions here or these groups don't have specific names, we do kind of call them something. So these ones in pink or purplish under this kind of stair-stepping line, we call those metals under the stair step. It's not an official name, but that's how I'm going to refer to them for the rest of the year. So we'll a lot of times talk about transition metals and the metals under the stair step because they kind of do some of the similar properties. And then these other things in green up here, we call them other nonmetals. So your noble gases and your halogens are also considered nonmetals, but these are just another group of nonmetals that don't have a very specific name to them. Okay.